We actually started last month, so I'm going to discuss today mainly our vision and future results. DICE, as I said, is a research and innovation action founded by Horizon 2020. The focus is on quality-aware development for big data applications. The project will last 3 years. Is a 4 million euros budget project, and the consortium is composed by several European partners. We have 4 academic partners: Imperial College, University of Saragossa, Politecnico di Milano, and EIT Timisoara, and 5 small and medium enterprises: Flexiant, NTC, XLab, Medfactive, and ProDevelop. So the motivation for undertaking a research on quality-aware software engineering for big data applications is, of course, that big data is growing rapidly in the market. There are, of course, a lot of statistics out that give very convincing figures that big data is growing and growing. But if you look at the last reports about the percentage of projects on big data in companies that are successful, you will see that we are not still at maturity level. So there are early stage issues for big data technologies, and the companies don't know how to develop high quality applications that rely on big data technology. So there is a statistics from Capgemini this year that says that 35% of big data projects in industry are successful, and all the others face issues and they are not deemed as successful upon completion. So there has been recently at European level a call for improving the software quality assurance techniques for big data, and we have identified an issue that motivates this project, which is the fact that there is a lot of effort upon improving functional modeling techniques for developing application, but there is not enough effort on improving the quality of the application themselves. So by quality I mean reliability, performance, cost efficiency, safety. And this is, of course, crucial for competitiveness. If you go on the market with an application that is not reliable or highly performing, you want to get a fair share of the market. So how do software engineering today support the development of high-quality applications? Well, one approach you might want to take is to use model-driven engineering. So you're going to use models like, for example, UML models to describe your application, and there are some methodologies that allow you to annotate these models with quality requirements. So if you want your application to have certain level of reliability, you can annotate some extensions of UML to require these reliability. And then there are tools which successfully transform these models from a high-level specification into a platform-specific specification, going through a round of description of the architectural characteristics of your software. And at each of these layers, the developers can add additional requirements and provide more information on what the application should do. And some of the research efforts that have been made in this area have found ways to transform these models into predictive models that can tell you in advance what will be the performance, the reliability, or the cost of your application before actually completing the development. So you can get a qualitative idea of the expected quality of your application as you develop. What we are trying to do here is to extend these methods to the big data domain. And big data, of course, has a lot of novel challenges. I'm sure you have heard about the 5 V's of big data several times. Data can come in large volumes. There is a velocity associated to data streams, variety, veracity, value, etc. So there are a lot of characteristics of data and data movement that introduce new challenges when we engineer big data applications, because it becomes, for example, difficult to tell what will be the reliability of your application if you don't understand what is the reliability of a Hadoop MapReduce, a NoSQL database, Spark, or any of the other big data technologies that you use to specify your application. And one of the aspects of complexity of understanding the quality of big data application is the fact that there are many such big data technologies. You can look also streaming, you can look at cloud storage, so it becomes difficult to be able to predict the performance and reliability of a system that has many heterogeneous big data technology. In addition, big data applications are cloud applications very often, either private cloud or public cloud, so you need to take into account the reliability also of the environment where you deploy your software. Another challenge that we face when we want to study the quality of big data applications today is the fact that there are a lot of DevOps methodology that have been proposed in the last few years that have changed the way we develop cloud software. So we need also to make more modern these quality-aware development techniques to take into account the fact that we have continuous integration, the fact that we have continuous feedback from the runtime environment to the developer, we have continuous monitoring, etc. So these are very important, challenging by themselves. And our idea is to develop an holistic approach, which we call DICE, that can handle all these challenges altogether. So what we have to achieve in order to be able to predict the quality of an application at the same time is, first of all, we need to be able to reason about the data that this application is processing. So how big it is, what data rates you have for the data you read or you write, etc. And then we are going to have a methodology in DICE that transforms the models going from a high-level specification to a platform-specific description of your application. And in these models, we will be able to describe the properties of Hadoop, NoSQL, databases, etc. There will be a DICE ID, which integrates all these modeling features. And one innovative aspect that we are going to introduce in this toolchain of integrating in our IDE is a set of tools for continuous monitoring of the application at runtime in such a way that you can quickly learn how your application is behaving. So if you want to do performance of reliability debugging, you can use data from the runtime environment that will be fed back to the IDE, and the developer will be able to inspect this data with the help of the tools we are going to develop in DICE. And of course, there are a number of benefits that we envision from the availability of tools like the ones we propose in DICE. First of all, if you are in a SME, in a small company, you might not have a lot of quality engineers that are highly trained in reliability analysis, performance evaluation. So we want to give you tools that automate to the best possible extent the task of predicting performance and reliability. And of course, the goal is to speed up the development process. So we want to help companies reduce the time to market for their big data applications. In addition, since we're going to reach the market earlier than without these techniques, we envision a decrease in the development time and cost. And of course, the ability to reason about quality before completing the application development, for example, by comparing the expected reliability of different possible architectures for your application, will give you the possibility to avoid implementation errors. And so we hope to be able to reduce the number and severity of quality incidents as you develop your big data software. So what are exactly the quality dimensions we are interested to investigate in the project? Well, there are essentially three: reliability, efficiency, and safety and privacy. So by reliability we mean fault tolerance, availability, and other aspects related to the continuous operation of your service. By efficiency, we look primarily to cost and performance. And in safety and privacy, we want to avoid that if you have an application in a domain where a failure might harm humans, this application behaves in a way that is unacceptable for the safety requirements. We will also consider aspects of privacy and data protection. So I just want to give you a high-level idea of what you will need to do to specify these DICE applications using the models I've discussed before. You will have at a high level what we call a DICE platform independent model. So you're going to describe in this model a number of data sources that you see here with these DS circles, which provide the data to computational logic elements that are able to process this data at a given rate that you can annotate in this model. So if you don't know what is this rate, our tools can progressively learn from monitoring data what these rates are. But the first time you develop the application, you will not know this, so you can just write there an expectation that you have. And this is a very high-level description that the developer will need successively to refine, specifying more features about the data. For example, where is the data located, what access control policies do you expect to implement for the data, etc. And as this refinement goes on, you will have to specify what we call a platform and technology specific model. Part of this specification will be done through automatically, so there will be automatic recommendations on how to refine the initial models to obtain these BPSM models. In these models, you would bind these computational logic elements to specific technologies, so you will be deciding here if you want to process data with Hadoop MapReduce or another solution that has similar functionalities, and we will provide recommendations on the best technology to use for the job. And finally, there will be a last level of the model specification where you will explain how to deploy these big data component technology and computational logic elements on the cloud. For example, you can say that you want a certain number of mappers and reducers on a certain number of virtual machines on your favorite cloud providers. So some of these specifications will be done manually, but several of these will be automated through tools that will suggest the most cost-efficient choices for your deployment. And in particular, we want to come to the point where our tools will be able even to recommend a deployment plan for your big data application. I want to conclude by mentioning that we envision to test these tools on 3 industrial demonstrators in the area of news and media, government applications that have to process legacy data sets, and for a geofencing application in the maritime sector. So there's an application to track vessel movements in ports. So this concludes my presentation.